In this lecture, we're going to wrap up the section on adding and subtracting rational expressions and simplifying complex expressions. So we're up to example 28, and before we get up to example 28, let's just talk about or remind ourselves how to add and subtract fractions, because that's really what we're doing. We're going to have rational expressions, and we're going to add or subtract them. And remember, rational expressions are just a quotient, or a fraction, but in order to add or subtract fractions, we need to have the same denominator. So in order to add or subtract rational expressions with the same denominator, we add or subtract the numerators, and then we place the result over the common denominator, and then we would simplify. So for example, if I had 1/7 plus 3/7, that would be 1 plus 3/7, or 4/7. We're going to do the same thing if we have a rational expression. So look at example 28. So in example 28, part A, we want to add x minus 2x divided by x squared plus 3x to x squared plus x over x squared plus 3x. So I see I'm adding fractions. I have a common denominator, so I'm going to add the numerators and put that sum over the common denominator. So this is going to be equal to x minus 2x plus x squared plus x divided by x squared plus 3x. Combine like terms in the numerator. So we're going to have x squared. And then we could combine the x and the positive x and the negative 2x, right? So x minus 2x is going to be negative 1x, and then I'm going to add x. So that's going to be 0. So we're going to have x squared divided by x squared plus 3x. And now, just like it says in step 3 above, simplify if possible. So we always want to simplify our answer. So I'm looking at this expression and I see that everybody has an x in common. So I'm going to reduce by a factor of x. The other way we could have done this is what we were doing in the last lecture when we were simplifying rational expressions. Factor each numerator and denominator if possible. So look, we could factor the denominator. I could factor out an x. So I'm going to factor out an x, and then we're going to have x plus 3. And I see I have a common factor, right? In the numerator and denominator, the common factor is x, so I could reduce by 1x. So I'm going to have 1x in the numerator, and then in the denominator, I'm going to have x plus 3. So x over x plus b would be my final answer. I'm sorry, x over x plus 3. Now let's look at part B. So for B, we want to subtract. I have a common denominator, right? It's x plus 1. So I'm going to subtract the numerators. But a quick reminder, whenever we subtract polynomial expressions, we need parentheses. So we're going to have x minus 3x plus 2. And I'm going to divide that by x plus 1. So let's distribute combine like terms in the numerator. So we're going to have x minus 3x minus 2 divided by x plus 1. X minus 3x is negative 2x. Then we have minus 2 divided by x plus 1. Let's see if we could factor the numerator and or the denominator in order to simplify. And I see in the numerator, I could factor out a negative 2. So once I factor out the negative 2, I'm going to, for my other factor, I'm going to have x plus 1. And that's over x plus 1. Now we're ready to simplify, and if there's a common factor in both the numerator and the denominator, we could reduce. And we see that we have an x plus 1 in both the numerator and the denominator. So that's going to reduce to 1, and we have times -2 in the numerator. So my final answer is going to be -2. So moving on, next we're going to look at how to add and subtract rational expressions that have different denominators. So we're going to have to look for a least common denominator. And I think before we go through the steps and look at example 29, it might be easier for me to make a simple example just to remind you guys on how to find a common denominator, and we'll do that on the other whiteboard. So for example, let's say we want to add 2/5 plus 3/7. Now I don't have the same denominator, right, for each fraction. So we have to rewrite each fraction as an equivalent fraction where they both have the same denominator. So what we have to do is we have to look for the least common denominator. So look at the denominators that we have. We have a 5 and a 7. I have two different factors, right? One's a 5, one's a 7. But if I take the product, I'm going to get 35, right? And that's going to be my common denominator. So let's do this. So let's rewrite two equivalent fractions where my common denominator is 7 times 5, or 35. So we can't just rewrite two new denominators without, making the numerators proportional or equivalent, right? So we need to rewrite a fraction here that's the same thing as 2/5, and this fraction here has to have the same value as 3/7. So whatever we did to the 5 to, whatever we multiplied by 5 to make it a 35, we have to do the same thing to the 2 in the numerator. And 2 times 7 is going to give us 14 over 35. So we multiply both the numerator and the denominator by 7, right? So 14 over 35 is equivalent to 2/5. And now for the other fraction, 7 times 5 is 35. So I have to multiply the numerator 3 by 5 as well. And we're going to get 15 over 35, which is equivalent to 3 over 7. Now we're ready to add the fractions because I have a common denominator of 35, and 14 plus 15 is 29. So my answer would be 29 over 35. And of course, if we could reduce that, we would. So that's how we write equivalent fractions with a common denominator in order to add or subtract. So now let's apply this concept to the examples that I have. And what I just did in that example on the whiteboard pretty much follows these same steps. So the first thing we have to do, find the least common denominator of the two expressions. Then we have to rewrite each rational expression as an equivalent expression whose denominator is the least common denominator, just like we did on the whiteboard. And we did that by multiplying the numerator and the denominator of each expression by the factor needed to convert the denominator into the least common denominator. Then we're ready to add or subtract the numerators. We place the result over the least common denominator, and if possible, we would simplify. So we're going to follow these steps. So let's look at example 29. So in A, I want to add 3 over x plus 4 plus 6 over x plus 5. So think about what we just did in the previous example on the whiteboard. I have two different denominators, right? One's an x plus 4, one's an x plus 5. They're two different factors, right? But if I take the product of the two different factors, right, of the x plus 4 and the x plus 5, now I'm going to have an LCD. So my least common denominator in this case is going to be x plus 4 times x plus 5. So what I want to do is we're going to rewrite each expression over the common denominator of x plus 4 times x plus 5, and then we'll be able to take the sum. But now we have to rewrite the numerators, right? So we keep that equivalent fraction. So we went from an x plus 4 to an x plus 4 times x plus 5. So we multiplied x plus 4 times x plus 5, right, to get this new LCD. So I'm going to do the same thing to the numerator. So we have to take 3 and multiply it by x plus 5. Now, in my second expression, x plus 5, right, was multiplied by x plus 4 in order to get the LCD. So I'm going to do the same thing to the numerator. So I have to take 6 and multiply it by x plus 4. So now I have two equivalent expressions, but they have a common denominator, and now I can add. So let's add the numerators. So I'm going to have 3 times x plus 5 plus 6 times x plus 4 over x plus 4 times x plus 5. And I can distribute and combine like terms in the numerator. So now really we have to think about simplifying. So I'm going to have 3x plus 15 plus 6x plus 24 over x plus 4 times x plus 5. We can combine like terms, and I'm going to continue down here on the next row to the left. So I have a 3x and a 6x, which is going to be 9x. And then I could combine the 15 and the 24, and that's going to be a positive 39. So I'm going to have 9x plus 39 divided by x plus 4 times x plus 5. Let me just rewrite that more neatly. Now we want to factor the numerator to see if we have any common factors, right? To see if we could reduce this expression. I see that we could factor out a 3 in the numerator. So if I factor out a 3, my other factor is going to be 3x plus 13. And then divided by x plus 4 times x plus 5. But that didn't really help us in terms of simplifying, right? Because there's no common factor in the numerator and the denominator. So this would be my final answer. So we really can't simplify this any further. So we have 3 times 3x plus 13 divided by x plus 4 times x plus 5. We could have also left it as 9x plus 39 in the numerator. That's fine also, because it really didn't make a difference. We weren't able to use the factored form, to simplify. So let's look at this next example. So let's look at B. So we have 3x over x minus 3 minus x plus 4 divided by x plus 2. So we're subtracting rational expressions, and we need to find an LCD, at least common denominator. So I have two different factors, right? In the first fraction, my denominator is x minus 3, and then my other denominator in the other expression is x plus 2. So I have two different factors, so I'm going to take the product to make the LCD. So my LCD in this case is going to be x minus 3 times x plus 2. So we want to write two equivalent fractions that have a common denominator of x minus 3 times x plus 2. So let's rewrite our numerators. We had an x minus 3, which became an x minus 3 times x plus 2. So the x minus 3 was multiplied by x plus 2. So we have to do the same thing to the numerator. So I'm going to take 3x and multiply it by x plus 2. Now, my second expression, my second fraction, x plus 2 was multiplied by x minus 3 to get my LCD. So I'm going to take the x plus 4 in the numerator and multiply it by x minus 3 also. So now I have two equivalent rational expressions, right? So they're equivalent to the original, except now they have a common denominator. So we're ready to perform the subtraction. So let's subtract. So we're going to have 3x times x plus 2 minus x plus 4 times x minus 3 divided by x minus 3 times x plus 2. So let's distribute and combine like terms in the numerator, and I'll continue on the next row. So let's multiply 3x times x plus 2. So I'm going to get 3x squared plus 6x, and then minus, now I'm going to do FOIL on the x plus 4 times x minus 3. So we're going to get x squared minus 3x plus 4x minus 12 over x minus 3 times x plus 2. And now we could distribute the negative in the numerator. So we're going to get 3x squared plus 6x minus x squared plus 3x minus 4x plus 12 over x minus 3 times x plus 2. Let's combine like terms. I have a 3x squared minus x squared, which is going to be 2x squared. We have a 6x, a positive 3x, and a negative 4x. So that's going to be 6x plus 3x is 9x. 9 minus 4 is going to be positive 5x. And then we have plus 12 over x minus 3 times x plus 2. So now we just have to see if our results can be simplified. So like we've been doing, we want to see if we can factor the numerator because the denominator is already factored, right? Let's see if we could factor the numerator and reduce by a common factor. So we did this in a previous video, right? When we factoring polynomials in the form ax squared plus bx plus c, we were using the AC method where we multiply a times c, and then we try to see if there's two numbers or factors that multiply to c and add to b, and then we could regroup the expression. So a times c in this case would be 2 times 12, which is 24. So we need to think, okay, are there two numbers that multiply to 24 but add up to 5? And there's not. So there's not, a pair of numbers that multiply to positive 24 and that will add up to 5. So the numerator is not factorable, and we can't reduce this any further. So that's going to be our answer. So let's keep practicing. I think these tend to be one of the more difficult types of adding and subtracting problems that we do, only because one, we're working with fractions, and two, we need to find a common denominator. So, and our denominators are polynomial expressions on top of it all. So I think, it gets a little bit confusing sometimes. So we'll do two more examples just to make sure you guys are comfortable. So let's look at C. So we have 4 divided by x squared plus 6x plus 9 plus 4 over x plus 3. We're going to do the same thing. We want to get the LCD by taking the product of the different factors that we have in the denominator. But notice with the other examples that we did, my denominators couldn't be factored. If we look at C, look at the denominator on the left, the x squared plus 6x plus 9. We can factor that first. So we're going to have 4 over, now two numbers that multiply to 9 and add to 6 are going to be 3, right? X plus 3 times x plus 3, which I could write as x plus 3 squared. So that's how I could factor x squared plus 6x plus 9. And then we have plus 4 over x plus 3. So let's think about least common denominator. My denominator on the left is x plus 3 squared, and my denominator on the right is x plus 3. So the least common denominator is going to be the larger one, the x plus 3 squared. So think about it like this. It would be like if I had 1 over, let's say, 3 and 1 over 3 squared, which is 9, right? My least common denominator would be 9 because 9 is divisible by 3. It's the larger number, right? So in this case, between an x plus 3 squared and an x plus 3, my common denominator is going to be the x plus 3 squared. So let's rewrite two equivalent fractions that have a common denominator of x plus 3 squared. So again, let's ask ourselves, all right, how did an x plus 3 squared become an x plus 3 squared? Nothing changed, right? So my numerator of 4 is not going to change either. But now let's rewrite this second fraction, 4 over x plus 3. How did this x plus 3 become x plus 3 squared? Well, it was multiplied by x plus 3. So now I have to take the numerator, 4, and multiply it by the same factor, x plus 3. Now we can add. So I'm going to have 4 plus 4 times x plus 3 over x plus 3 squared. We can distribute and combine like terms in the numerator. So let's continue down here. So we're going to have 4 plus 4x plus 12 divided by x plus 3 squared. Combine like terms, 4 plus 12 is 16. So we're going to get 16 plus 4x. Or normally we would write the x term first. So I'm just going to write the 4x first. So 4x plus 16, same thing, divided by x plus 3 squared. And now we have to ask ourselves, all right, can I simplify this expression or is it already simplified? Well, remember what we do. Factor the numerator and or the denominator and see if we can reduce by a common factor. The denominator is already factored. I see in the numerator I could factor out a 4, and then I'm going to get times x plus 4. And then we have over x plus 3 squared. But there's no common factor, right? So even though I was able to factor, there's no common factor that we could reduce by. So 4 times x plus 4 divided by x plus 3 squared is going to be my final answer. Let's do one more. So for part D, we have 3x over x squared plus 3x minus 10 minus 2x over x squared plus x minus 6. So what I would do, like in the previous problem, factor any denominators that are factorable. And in this case, both denominators are factorable because you need to see what the factors of your denominator are in order to find the least common denominator. So let's rewrite this as 3x over, now to factor x squared plus 3x plus 10 minus 10, what are two numbers that multiply to negative 10 and add to 3? So that's going to be x plus 5 times x minus 2 minus 2x over, now factor x squared plus x minus 6. Two numbers that multiply to negative 6 but are going to add to 1. And that's going to be x plus 3 times x minus 2, because 3 times negative 2 is negative 6. 3 plus negative 2 is 1. Now I could see the factors that make up my denominator. So remember what we've been doing for all these previous questions. In order to get the least common denominator, form a denominator using the different factors of our two denominators that we have, right? So what I mean by that is, look, the denominator on the left has two factors, x plus 5 and x minus 2. The denominator on the right has two factors, x plus 3 and x minus 2. So there's three different factors that I see all together, an x plus 5, an x minus 2, and an x plus 3. So we need to take the product of the different factors in order to come up with the LCD. So my least common denominator is going to be the product of, and you know what? I'm going to have more room down here. So I'm going to do this down here. So let's continue this down here. So my least common denominator is going to be the product of x plus 5 times x minus 2 times x plus 3. So now we have to rewrite the numerators accordingly, right? So I'm going to multiply 3x by the additional factor, right? 3x needs to be multiplied by x plus 3. And then the 2x needs to be multiplied by the additional factor, which is x plus 5. Now we can subtract. So I'm going to have 3x times x plus 3 minus 2x times x plus 5, and then divided by x plus 5 times x minus 2 times x plus 3. And now we can distribute and combine like terms in the numerator. So we're going to get 3x squared plus 9x minus 2x squared minus 10x over x plus 5 times x minus 2 times x plus 3. I'll continue on the next row. So let's combine like terms in the numerator. So a 3x squared minus 2x squared is going to be 1x squared. And a 9x and a negative 10x is going to be a minus x. Divided by x plus 5 times x minus 2 times x plus 3. So I have my result, right? We subtracted the two rational exponents by finding a common denominator, but now we need to see if we could reduce this. And I see that I could factor the numerator, x squared minus x. We could factor out an x, so we're going to have x times x minus 1 divided by x plus 5 times x minus 2 times x plus 3. And even though we were able to factor the numerator and both the numerator and the denominator, are factored, there's no common factors, right, that we could reduce by. So this would be my final answer. Now I'm going to stop this lecture here. I thought I was going to get through the complex rational expressions, but I don't want to make this lecture too long. So I'm going to split this section one more time. So in the next lecture, I'll finish this section and we'll finish complex rational expressions.